So next up we have the Proterozoic eon. Once again, it is an eon, which lets you know how long it is relatively. And because it stretches for such a long time, around 2.5 billion years ago to 540 million years ago, quite another long division of time, that lets you know that not a whole lot is happening in terms of life, geologic activity, stuff like that. But some interesting things that do occur, big things. Aside from changes, of course you have to keep in mind all throughout things like the oceans, the atmosphere, the crust are changing gradually. But one of the first things we see here are Ediacaran, I believe that's what they're called, biota or Ediacaran life, which are some of our first multicellular organisms. They're kind of those they look sort of like little fern-shaped almost, or oval-shaped little organisms. But the big takeaway here is that they're our first multicellular organisms. They date back to around 600 million years ago, I believe. And we also have our first oxygen-dependent or aerobic organisms. So we get a little bit of development in life, moving up from single-cell bacteria to some multicellular organisms, and not just anaerobic algae. Instead, now we're having some oxygen-dependent aerobic organisms. But overall, not a whole lot of development in these Precambrian pieces. That's why frequently all of these, the two eons I just discussed, are just lumped in with Precambrian, and we don't do a whole lot of discussion about them for that reason. However, now we're getting into the Proterozoic, or no, excuse me, the Paleozoic era, not the Proterozoic eon. The Paleozoic era, which contains the first period, the Cambrian period, which is very interesting for one big reason. So the Cambrian period was between about 540 and 485 million years ago, so instantly you can see that this is a much shorter period of time because a lot more is happening. And the big thing that happens is what we call the Cambrian explosion, or sometimes the explosion of life, because this is where we get a ton of development in living organisms. This includes huge diversity in both plants and animals, short time, relatively short time. So it's like you're getting a lot of progress in very little time. And I think one of the, this was, correct me if I'm wrong, but I think this is when the first shelled organisms appeared. I think I know that off the top of my head. Fossils aren't exactly my strong suit, but I think this is when you have the first shelled organisms appear. So Cambrian period, big takeaway, Cambrian explosion, explosion of life. This is where we start to see much larger diversity, not just single and multicellular organisms. This is where we start to see some shelled animals, more diversity in plants, that sort of stuff. That's a pretty easy one to remember. And then following up after the Cambrian period, we have the Ordovician, which is a pretty fun word to say. And once again, this is a period, not an eon, and it is between 485 and 444 million years ago, about. I'm not being perfectly exact here, just for the sake of giving you a general overview. But This one is generally known for the, quite importantly, the first actual fish and other marine invertebrates, not necessarily fish, but other marine life. And these include, notably, hopefully you recognize these trilobites, you know, the little guys with the heads and then a bunch of little, a couple of eye receptor things, and they've got the spine that goes down. You know, those sort of things. You hear about those fossils all the time. Things like graptolites, which are pretty interesting. They look like those little marks on rocks in the fossil form. Graptolithina, they look like, almost like hieroglyphs, I think. They're pretty interesting. Some look more like that, but things like that, and then cephalopods. How do you spell cephalopods? I was never an expert speller, but I think that's correct. Which, of course, you know, would be things like squid. So yeah, Ordovician, known largely for a large development in marine life, which makes sense. Marine development comes before terrestrial development, naturally. And then moving onwards, we have the Silurian period. It's another pretty fun, a lot of these are fun to say. Which is between 444 and 419 million years ago. And this one is known for not so much too much development in life, but we do see, importantly, the Earth's climate really stabilizes. Which is, of course, important to the development of future life. And with that, we see that sea levels rise. And we see some other developments with marine life, such as our first jawed fish. Our first corals. And our first, this is an interesting one, first vascular plants, which, if you don't know what vascular plants are, they're basically like plants that take root, they've got stems, basically they sound like modern day plants. That's the best way I can describe them, really, without going too in depth. Just think modern day plants, you know, not like those disgusting prehistoric ones. So that's the Silurian. And then moving onwards, once again, we come up to the Devonian period.